Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss about balancing of redox reaction. Balancing of redox reaction, this is very important in all examination. This question is asked, particularly for engineering. Okay. Then here some steps are there you have to follow during balancing of redox reaction. Okay. Then here two methods are there. Two methods are there to balance the redox reaction. First method is oxidation number method and second is half reaction method. Then now I am going to discuss, first I will discuss oxidation number method. Okay, then here 5 steps are there you have to understand. Okay, then what is the steps step wise I am telling you and remember it. Then after that if you will apply while this balancing the equation, this step you have to follow. First step I am talking about, write the correct formula for each reactant and product. This is the first step. Write the correct formula for each reactant and product. Step 2, identify atoms which undergo change in oxidation number in the reaction by assigning the oxidation number to all elements in the reaction. Means you have to, after writing the formula for each reactant or product, you have to identify atoms which undergo change in oxidation number. Okay, this is the second step. You have to identify atoms which undergo change in the oxidation number in the reaction by assigning the oxidation number of all elements in the reaction. Means you have to calculate oxidation number for each atom, for the reactant also, for the products also. Third step, calculate the increase or decrease in the oxidation number per atom and for the entire molecule or ion in which it occurs. If these are not equal, then multiply by suitable coefficient so that these become equal. If reactant side, product side, all atoms must be balanced, then you try to balance the atoms. Okay, atoms you have to balance it, left side and right side, means reactant side and product side. Okay, atom you have to balance by the changing in coefficient. You have to change it by multiplying by suitable coefficient so that these become equal. If you realize that two substances are reduced and nothing is oxidized or vice versa, it means something is wrong. Either the formula of reactant or product is wrong, or oxidation number have not been assigned properly, means you have not calculated properly. Now means you have to check it. Step 4, ascertain the involvement of ions if the reactant is taking place in water. Now there are three conditions that reaction may take place in water. First condition means neutral. Second, it can take place in the presence of acid. And third, in presence of base, means alkali. Okay, then three conditions are there, that reaction may take place in water, second in acidic medium, third in basic medium. Okay, then now step 4 is related to that. Ascertain the involvement of ions if the reaction is taking place in water. If reaction is taking place in water, add H ion or OH ions to the expression in the appropriate side, so that the total ionic charge of the reactants and products are equal. You should add H ion and OH ion to the expression on the appropriate side, so that the total ionic charge of reactants and products are equal. If the reaction is carried out in acidic solution, use H plus ion in the equation. If in acidic medium, if reaction is going on in acidic medium, then add H plus ion in appropriate side in the equation. And if basic medium, if reaction is taking place in basic medium, then use OH ion in the equation. Okay, this I have told you as a fourth step, means if reaction is going on H2O in the neutral in H2O, or second in acidic medium, or third in basic medium. Okay, then you have to, for the acidic medium, you have to introduce H ion, and for the basic medium, OH ion at appropriate side, means reactant side or product side. And last step, that is make the number of hydrogen atom, because you are adding H ion, then this H ion must be balanced with the other side, right side or left side, wherever you are introducing, then it must be balanced. Okay, either OH ion or OH ion you are reading, then that also must be balanced. In acidic medium, basic medium, you are adding acidic medium H ion, it will involve, and basic medium OH ion, then it must be balanced. Then for that purpose, you have to introduce H2O in opposite direction. Okay, if H ion is left side, then H2O will be right side. If H ion you have written the right side, means product side, then H2 in the left side. Okay, then step 5 is related to that. Make the number of hydrogen atoms in the expression on the two sides equal by adding water, H2O, by adding water molecule in the reaction or products. Now also check the number of oxygen atoms. If there are the same number of oxygen atoms in the reactants and products, the equation then represent the balanced redox reaction. Okay, now I am giving 1-2 example, then you can understand well. Okay, only these steps will be followed here. Then now question I am reading, problem I am reading, then after that I will solve it. Okay, I will balance it. Then question I am reading, write the net ionic equation. Write the ionic equation, means here ion term will be there, not full molecule ion. Okay, write the net ionic equation for the reaction of potassium dichromate. Oxidation state is 6. Means K2Cr2O7, then chromium has 6 oxidation state. With sodium sulfite Na2SO3 in an acidic solution to give chromium third ion in the sulfate ion. This is the question. Again I am reading. Write the net ionic equation for the reaction of potassium dichromate 6 oxidation state 6 with sodium sulfite in an acid solution to give chromium third ion and the sulfate ion. Means reactant and product they have given. Reactants and products they have given. Then reactant is here K2Cr2O7 plus NO2SO3 sodium sulfite. These are the reactant, and product given that reaction is going on in acid medium, and product is given chromium third ion and the sulfate ion. 2 reactant, 2 product. Then this is given in the question. Then now you have to balance the equation. Okay. Then now first you have to write a step 1. Because it is a potassium dichromate, then you have to write in the term of ion. Then potassium chromate is there, then you can write, can say chromate ion. Potassium you remove, K2. Then K2 means 2 plus, K has plus 1, then 2K you have removed. 2K you have removed, 2 plus gone, then 2 minus is remaining. Okay, then chromate Cr2O7 will have 2 minus, because potassium chromate K2 was there, then each K has plus 1, then now 2 plus gone, then 2 minus will be remaining, because finally potassium dichromate was neutral. Potassium dichromate K2Cr2O7 was neutral, means 0, upside sign was 0, then K2 gone. You have removed the K2, then Cr2O7 will be minus 2. Then this minus 2 in the ion, complete chromate ion has 2 negative charge, not the particular atom. Like chromium and oxygen. This charge, minus 2 charge, is on the whole ion. Then here you have to write Cr2O7 minus 2. Okay. Now sulfite plus sulfite, then it was question they have given sodium sulfite. Then now here NO2 again you have removed. Then now SO3, on SO3 it will come 2 minus. SO3 will come 2 minus. Okay. Then this is again, this 2 minus is on the whole sulfite ion, or sulfite ion 2 minus is there, not on atom by, not on sulfur, not on oxygen, on ion whole. Okay. Then this is the reactant side. Reactant side you have written chromate plus sulfite. Now come to the product side. Then product side already given, chromium is there. Then chromium ion is there. Then that is the, you have written chromium ion Cr3 plus will be there. Chromium ion will be Cr3 plus. Okay. And already oxidation state is, they have given 3. And another product is sulfate ion, SO4 2 minus. Then what is the question? Accordingly you have written here step 1. By with the help of question, you have a step 1 you have followed. Means step 1 you have written Cr2O7 2 minus plus SO3 2 minus, all are in aqueous, AQ. And product you have written chromium Cr3 plus aqueous plus sulfate SO4 2 minus aqueous. This is the step 1 you have written. Now I can say your balancing process is going to be started. Step 1 is over. Then now you can see here that now step 2, assign oxidation number for the chromium and sulfur. Now you should calculate oxidation number and write on the head of atom. on the head of atom or upside. Then you calculate the in Cr2O7 2 minus. You can calculate the oxidation number of chromium. Easily you can calculate. Already many times I told you 7 oxygens are there and 7, then chromium you want to calculate Cr2, then 2x plus 7 into minus 2, that is the minus 14, that is equal to minus 2 because on iron 2 minus is there. Then now minus 14 you write to the right side, then minus 2 plus 14 means plus 12, then 2 Cr is equal to 12, then Cr is equal to 12 plus 6. Then chromium oxidation number is top, you can head you can write plus 6. Oxygen already you know that it is a minus 2. Then chromate is over. For both you have written chromium and oxygen. Now sulfite also you can write SO3. Then SO3 like that way, what I told you in that same way you can calculate. Then sulfur will come plus 4 and oxygen is already minus 2. Then reactant side is over. Product side, chromium already it is given 3 oxidation state, means chromium is plus 3 only. And sulfate side, again you can calculate very easily. SO4 2 minus is there, then 4 minus 2 minus 8, right side it will go, then plus 8, and overall charge is minus 2. Then S minus 8 is equal to minus 2, then S is equal to plus 6. Then like that way now you have written the oxidation number for chromium and sulfur. Okay, then by seeing all these things, this reaction, now according to oxidation number you can tell this, according to this reaction I am telling you, this indicate that the dichromate iron is the oxidant, means oxidizing agent, means it will accept the electron, it will take the electron. Okay, and the sulfite ion is the reductant, it will lose the electron. Reductant always will lose the electron. Reductant means reducing agent, and oxidizing agent always will take the electron. Okay, then now step 2 is over. Step 3, now calculate the increase or decrease oxidation number and make them equal. Oxidation number you have to make them equal. Then here you have to consider that atom also you have to make equal atom, because atom also must be equal and charge also must be equal. This is the important things in balancing the ionic equation or balancing the redox reaction. These 2 points is very, very important. 4 points are very important. 5 points I told you. Then now after writing the expression, now atom wise you have to equate atom and charge wise also. And H ion already you told you, H ion, OH ion, H2O, all things you have to add that already by and automatically you can write also, because you have to balance the H ion, OH ion, then automatically you will write. Then now here step 3 I was talking about. Now Cr2O7 is there, and product side Cr is there, only one chromium is there. Then chromium first you have to balance is, then Cr2, and product side only one chromium is there. Cr2 in that oxidation number is 6 for chromium, in Cr2O7 plus 6, and in this chromium plus 3. Okay, already given question also, plus 3. Then now charge you have to, atom you have to balance. Then Cr2, then here you have to write under compulsion 2 Cr. Then atom is balanced. Cr2 was there, now this side, right side, product side, 1 Cr was there, now you have written 2 Cr, 2 you have introduced. Then chromium atom is balanced. Then now actually right side and left side total charge at least for positive or anyone should be you can say balanced. That you try. Okay, left side total positive charge, right side total positive charge, try to bring it equal. Okay, there will be either positive or negative, anyone you try to, anyone, not both will be balanced only in the end. Okay, not in the beginning. Then now you are trying here to positive charge should be balanced. Left side total positive charge must be equal to the right side positive charge. Right side means product side. Then now you can see chromium has +6 charge. +6 charge. Then 2 chromium is there. I'm talking about the left side, reactant side. Then now Cr2. Then 1 chromium +6. Then 2 chromium 12. 2 chromium 12. Okay. Then now chromium is 12. Now like that way here left side all positive charge you have to calculate, and all negative charge you have to calculate for the reactant. How many positive charge is there, how many negative charge is there for both. Reactant side first you are seeing. Then here you can see total positive charge, how much is there. Then 2 chromium is there, each chromium +6 means 12. And after that you can see that sulfur has you can say +4. Then now if you will actually one more things here, that reactant side sulfite is there and product side sulfate is there. Then here some coefficient you have to write. Coefficient you have to write. Then so that at least one, either negative or positive, any one should be same both side. Then here for positive side I am talking about the chromium is positive. 6 into 2 12. 12 are there, 12 positive charge. Okay, and this sulfur side, sulfur +4 is there. Then how much it became? Then this became 12 plus 4. 12 plus 4, 16. 12 plus 4, 16. And here you can see right side, product side. Then chromium was +3. Then 2 are there. Then 6. 6 positive charge. And sulfur side again +6. Sulfur on sulfur +6 charge is there. Then now 6 plus 6 12. Right side 12, left side also 12, means product side 12 and here also 12. Hence now this chromium is balanced, positive charge is balanced, left and right. Okay, then here now this you have balance, positive charge is balanced. Then now come to the, you can say, negative charge. Then for negative charge simply it will be not balanced. Okay, you have to go further steps. Then here rough idea by guessing you can put for sulfite and sulfate what coefficient is required. Then this you have to just you can start with minimum from the 2 just because one already is given. Then now 2 you can apply, I can see it is fitting or not. It will not fit completely, but it should be near about. Okay, then 2 it will not fit. 3 if you will put, then also it will not fit, but you are close. Then if you write 3SO4, left side 3SO3, then same things because atom you have to balance, then 3s you are writing, then here right side also 3SO4 you have to write. 3SO3 left side, reactant side, then product side 3SO4, then atom wise it is balanced. What you will write left side, that you have to write right side, because atom you have to balance. If 2 are writing, then both side you to write. 3 you are writing, the both side, because both have this coefficient has only SO3, SO4. And so whatever you write left side, that you have to write right side. Then now 3 you are writing. Then by writing 3, now you can check what is happening. Total positive and total negative. At least one should be equal. Now after writing coefficient, now you can see what is the effect on the charge. Then again you count positive charge. Then chromium, total chromium plus 12. Already you have calculated, plus 12. And sulfur 3SO4 you have written, 3SO4. Then 1s is plus 4. Then 3 are there. Then again it became 12. 1s is plus 4, then 3s you have written, 3 you have coefficient. Then now again 12. Then 12 plus 12, 24. 12 plus 12, 24. Left side. Then now right side you can see how did it affect. Then now 2 chromium was there, each chromium plus 3. Then 6 plus 3SO4, then 1 sulfur is plus 6. Then 3 sulfur means 18. 3 into 6, 18. Then 18 plus 6, 24. Means chromium 3 plus was there, into 2 chromium was there, then 6. And here 18, then 6 plus 18, 24. Then left side, right side, right side. Now it is 24. It means what you have written, that is solving some problem. Okay, it means you are going in a right direction, because at least positive charge is going to be equal. It means that is good. If you write any other number you will write, then you can say it will not fit. But anyhow, you write 2, 3, whatever you want to write, and see the situation. If it is a balancing, at least positive, both will not balance. Both will balance only in the end. Then after this charge atom you have balanced, and charge any one charge you have balanced, positive. Now all things should be balanced. Negative also should be balanced. Then now come to the step 4. As the reaction occurs in the acidic medium, according to the question, as the reactions occur in the acidic medium, and further the ionic charge are not equal. Now negative we have seen, it is not equal. And further the ionic charge are not equal on both sides. Then we have to add hydrogen, 8H you have to add. We have to add 8H on the left to make ionic charge equal. Why 8? Then here because charge is not balanced. Which charge? Negative charge is not balanced. Okay, negative charge, how much charge is there? Negative charge. Then you can see positive we have counted, but negative it will not balance. Then see here SO3, right side, left side first to see, reactant side, SO3 2 minus. SO3 2 minus is there. Oxidation number of oxygen is 2. And SO3, then each oxygen is minus 2, that means 6. 3 into 2, 6, minus 6. And total number of coefficient is 3. Then 6 into 3, 18. 6 into 3, 18 negative charge. Okay, 18 negative charge in the sulfite. And here in chromium Cr2O7, negative charge is 7 into 2, 14 negative charge. Okay, 14 negative. And on iron negative charge is there, that also you have to consider. On complete iron negative charge, that also you have to consider. Then here 7 oxygens are there, then 7 into 2, 14 and 2, overall 2 negative charge is there. Then 14 plus 2, 16 charge this side, and sulfide side SO3 you have seen, SO3 then 2 oxygen is minus 2, then 3 into 2, 6 and coefficient is 3, then 18. Then here 18, and again you have to add on iron 2 negative charge was SO3 2 minus, then coefficient is 3, then that 6 also you have to add. Then total sulfite including charge on iron, how much will come? Then 6 into 3, 18 plus 6, 24, 18 plus 6, 24, okay. And this side how much you have calculated? Chromium side. Then here you have calculated, say 7 into 2, 14 plus 2, 7 into 2, Cr2O7, then 7 into 2, 14 and 2 charge, 14 into 2, 16, then 16 plus 24, how much? Then 16 plus 24, and that it will come 16 plus 24, 20 plus 24, no? 24, then become 40, okay, 40, 24 plus 16, it is 40, 40. Then total negative ion is 40, and this side, right side, if you will calculate, then how much negative charge? Then SO4, 3 SO4 is there. Then here SO4, 4 oxygen is there, then 4 into 2, 8 oxygen, and 8 oxygen and 3 SO4 is there, 8 into 3, 24, 8 into 3, 24, and SO4, 2 negative charges on iron, 2 negative charge, then 3 into 6, then 24 plus 6, 30, okay. Again you count that here SO4, 4 oxygen atom, then 4 into 2, 8 into 3, 24, and oxygen is 2 minus on iron, then 3 into 2, 6, then here this is becoming how much? That is becoming 3 SO4, 4 into 2, 8 into 3, 24 plus 6, 30, then 30 is there, right side 30 is there, and left side it was there difference would come only 8 difference would come. 1 minute, only oxidation number you count, only oxidation number, then it will be clear, it is becoming big number. Then now Cr2O7 is there, then negative charge I am counting out, then 2 negative charge, okay. Cr2O7 on whole ionic number, 2 negative charge, and sulfide side SO3, okay. Then SO3 means in one SO3 2 negative, then in 3 In 3 it will become 6. Then 6 plus 2, 6 plus 2, 8. 8 negative left side, reactant side. And this side it will become how much? Then here again it is becoming O4. SO4, 2 minus is there. 2 minus is there. And this things SO4, 2, 3 into 2, 6. 3 into 6. Here you will see that reactant side and product side, that is the 8 difference is coming, 8 difference. That's why where you can say more is coming, where more this will come, negative side, negative charge is more. Then here 8 negative charge will be more. And then for equating purpose, because you have to bring both sides equal, then 8 hydrogen you have to write. Then both side negative sign will be equal and positive sign will be also equal. 8 hydrogen, while if you write and count, then you will find that now 8 hydrogen you are writing, then 8 hydrogen if you will write, then negative is equal. Negative will become equal both sides after writing 8H. 8H, because you can say left side negative is becoming more. 8 extra is coming in comparison to the left side. Then if you write 8H, means positive, 8 positive we have written, then now negative charge is equal. Negative charge equal. Then now 8H is there. Then because only left side hydrogen is there, right side, left side only first time you have used the hydrogen in equation, no hydrogen was there. Then 4 hydrogen you have to balance it. Then if you will balance the 4 hydrogen, 8 hydrogen to balance it, then your right side, opposite side where you have 8H written, then opposite, left side 8H you have written, then right side 4H2O you have to write, 4H2O. Then 4H2O means 8 hydrogen is balanced. Then if you will count now oxygen also, then you will find everywhere oxygen, hydrogen, all atoms are fully balanced. Okay. Then here like that way, this I told you 5 step I have told you. 8 hydrogen you have introduced. Then right side you have to introduce H2O. 4 H2O means 8 hydrogen balanced, and 4 H2O means 4O extra it went. Then whatever was oxygen was not balanced, that now it is balanced left side. Keep in mind that simply in any one step you can't balance all oxygen, all hydrogen, oxygen, you can't balance only in one step. But step by step you have to follow. Chromium you can balance, no problem. But oxygen to balance the oxygen and charge, partially you can balance for chromium like this things, metal, not for oxygen. Oxygen it will be balanced only in the end. Okay, but only metal positive, that at least any one you have to balance, particularly metal only, metal like chromium to balance. After that rough you can write, and then exact after writing introducing the hydrogen ion where negative charge is more, that side you write hydrogen atom, so that negative and this positive both will, if negative is more, then this hydrogen positive that will cancel out. Then what was the left side? That will be the right side. And then because you are introducing hydrogen, then now you have to add water opposite side. Left side if hydrogen 8H you have introduced here, then right side you write 4H2O. Then now you will see oxygen is also, atom wise oxygen is also balanced, charge wise also balanced. One step one like fourth step what we were calculating. In that way you will find it is difficult, it will not fully balance, some differences will come. Okay, then this is the now balanced equation I am talking about in fifth step. That actually fourth step you have to think. Third and fourth is important step. Their main balancing we are doing. For you first you put the balancing for the metal, that you can do. For oxygen, there it will be next step, only it is possible when you will add hydrogen and the opposite side water, only then oxygen will be balanced or charge will be balanced. Okay, then wherever oxygen is charge is becoming more negative charge, that side only hydrogen in that number you have to add, so that what was the right side negative, the right side negative was less, left side means reactant side negative was more. That's why you have introduced hydrogen, so that now negative will be equal, negative both sides will be equal, and to equate the hydrogen, 8 hydrogen, opposite side, left side you have written, then right side you write 4s2o. Then this side oxygen will be also balanced, charge will be also balanced, all things will be fully balanced. After balancing one time just to check it, atom is balanced or not, total positive charge is balanced or not, total negative charge count. If it is balancing, then it is a complete balance equation. Now another problem I am telling you, that is the permanganate ion question I am reading problem. Permanganate means KMnO4, potassium permanganate. Permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ion. Write the balanced ionic equation for the reaction. Okay, permanent ion, again reading the question. Permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ion. Write the balanced ionic equilibrium for the reaction. Now in question reactant and product they have given, but it is not balanced. Then now again you follow the 5 step and you can balance the equation, ion equation. Then permanganate ion they have given in question. Then permanganate KMnO4 is potassium permanganate, KMnO4. Then K if you will remove, means 1 plus charge gone, then MnO4 1 negative will develop. MnO4 1 negative will develop. Because when potassium will be there, then 1 positive 1 negative both will be equal. Then now KMnO4 was 0, no charge. Then K went. Then K went means K plus, 1 plus went, then MnO4 1 minus will come. Then this magnet MnO, then this permanganate ion you have written MnO4 1 minus aqueous, because reaction is taking place in basic medium, you keep in mind. Then this is in solution magnet ion. And bromide don't know that Br 1 minus, just like fluoride, chloride, bromide, only one ion is there, one negative charge will be there, Br minus. Then now reactant side is over, reactant side is left. Right side means product side. According to the question they have given, manganese dioxide is formed, MnO2. MnO2, right, MnO2. Plus other product is bromate ion. Bromate ion means bromate BrO3 1 minus. BrO3 1 minus, bromate ion. Okay, this formula you have to keep in mind. Only then you can write the solve the balance the equation. Otherwise it is not possible. Then now first step is over. You have written MnO2 plus bromide ion, MnO2 1 minus, bromide 1 minus, and product side MnO2 plus MnO2 no charge, BrO2 1 minus. Now after that And step 2, you will write step 2, you have to write the oxidation number. Then now easily you can write for MnO3, Mn has plus 7. If you calculate, you will get Mn plus 7. Bromide already minus 1 is there. MnO2, Mn is plus 4. Very easy. MnO2 minus 2 into minus 2 minus 4. That is equal to 0. Plus 4 it will come. Mn is plus 4. And bromate ion, you will see. Then bromate also you can solve very easily. BrO3. BrO3, 1 minus. Then 3 oxygen is there. Then 3 into 2, 6 minus 6. That is equal to minus 1. It will go that side. Then 5. Then bromine is plus 5. Oxidation number of bromine is plus 5. Then now here you have calculated the oxidation number. And by seeing the oxidation number, you can tell this indicates that this reaction after writing oxidation number indicates that permanganate ion is the oxidant, means it is accepting the electron, and bromide ion is the reductant. It is the losing electron. That's why here Mn plus 7, it become plus 4 because it accepted the electron. Plus 7, it means they have taken negative, means electron. Now it became Mn plus 4. That is the reducing, that is the you can say oxidant, oxidizing agent. And because it is accepted, and bromide ion, now from minus 1 it became to plus 5. It lost. That's why it is reductant, means reducing agent. Step 2 is clear. Step 3. Now check the 3 and 4 is very important. Then now step 3, calculate the increase and decrease of oxidation number, and make the increase equal to decrease. Okay, increase must be equal to decrease. Then now you can see atom wise, you can see balance. In this you have seen MnO2, MnO4 became MnO2. Okay, Mn is balanced, manganese is balanced, bromium is also balanced, oxygen number is atom is not balanced. Okay, because O4 was there on this side, product side O2 and O3 is like that. Then now to charge, for the charge balance, atom is balanced. Okay, then for charge balance you have to write left side, you write 2MnO. Okay, because I told you total increase must be total decrease. Then now if you will write 2MnO, then what will happen by doing these things? 1 Mn means plus 7. 1 Mn means plus 7. That 2 Mn means plus 14. Then now 2 Mn you have written, because 2 Mn was already balanced. Then 2 Mn you written left side, then right side also you write 2 MnO4. Then by this way you can see what is the, you can say, oxidation state. Then now you can see it is a 2 into 7 into 2, 14, left side, Mn, 14. And here right side, Mn became now 8, 2 into plus 4, 2 into 8. Okay, then now you can see this thing, both reactant side complete, you check it, total number of positive and total number of positive. Then here 14, only 14 was there, Mn plus 7 and into 2, that is the 14. Okay, and 14 and MnO4, MnO4 one negative was there on complete anion, one negative was there. Then coefficient is 2, you have balance, then it become 2 negative, then positive was 14 and negative is 2 in this molecule MnO4. Then now 14 minus 2, it became 12. Okay, and 12, and now you can say one bromide ion. Then now from this 12 again 1 you reduce, plus 12 was there, minus 1. Then here you have seen 17, from the 17 you have 2 into 7, 14, from 14 minus 2, because on MnO4 1 minus was there, then 2 MnO4 means 2 minus, then 14 minus 2, it became 12 positive, and here in bromide ion only 1 is there, only 1 negative is there. Then from this 12 1 more negative will go, then 11 positive will remain. Now this side you can see how much total positive charge is there, total charge, then 2 MnO4 right side, then 8, it becoming 8 positive charge, and bromide was there 5 plus 5, then 8 on 5, 13. Okay, then now you can see 13, and if that bromide BrO3 1 minus was there, then now it became 13 minus 1, 12, it is not balancing. Okay, then now here just here you have to balance the oxygen balancing is required, rough idea I have written. Then 2 both, actually in any equation if you are doing same thing both side, it will not affect. Then here you have written that you have to balance only charge, you have to balance, but in one step it will not balanced. Okay, then in this step, in step 3rd, here increase and decrease of oxidation number, and that you have to calculate and make the increase equal to decrease. Okay, for that purpose coefficient you are adding. Okay, but despite that it will not fully balanced. Next step you can see, as the reactions occur in the basic medium and the ionic charge are not equal on both sides, then what will you do? How much difference is coming? Then here you will find that there is a difference, charge is not balanced, then 2 OH you have to add because reaction is basic medium, then add 2 OH ions on the right side, because there is a difference of 2 negative charge, 13 and 11. You have already calculated. One side it was 13, right side, left side was 11. 2 difference was there. Then 2 difference was there. Then 2 OH you are adding. Add 2 OH ions on the right OH, because it was becoming more. There was 13 positive, then 13 positive and minus 2 OH, then it will become 13 minus 2, that will become 11. Then now both sides will be equal. Then 2 MnO4 plus bromide ion, then right side product side 2 MnO4 plus BrO3 plus 2 OH you have added. Then now 2 OH you have added, then now oxygen is balanced, charge is also balanced. Okay, but hydrogen is not balanced. Right side 2H is there. Then how will you equate? Then now left side, right side 2H, Right side hydrogen is there, on the left side no oxygen, no hydrogen. Hydrogen is 2OH, then hydrogen increased only to the right side. Then left side also should be there. Then 2OH means 2 hydrogen you have to bring left side. That's why you have added 2H2O. Only one H2O. One H2O means 2 hydrogen came. And along with hydrogen, oxygen also came. Then now if you will see oxygen wise, hydrogen wise, then you will find that both side number of hydrogen and number of oxygen is equal. Already manganese and bromide is already equal. Hence now equation is fully balanced. Okay. Then now I am stopping only here, and second also is there, half reaction method. Then this is again long, then I will discuss it in the next class. Okay, thank you.